Welcome back to Share Science, the weekly science brief for July 27th, 2026. I'm Curie.
And I'm Derek. Curie, this week we are starting with a planet 48 light-years away that may be more like ours than we thought. Give the folks the tour.
Okay, so imagine this. A rocky planet, 48 light-years away, orbiting a star that blasts it with radiation. And yet, it's holding on to an atmosphere. That's the kind of discovery that changes how we think about the search for life in the universe.
That's incredible. For years, the assumption was that planets around red dwarf stars couldn't keep their atmospheres because of all that radiation. But now we know that's not always true?
Exactly. The planet is called LHS 1140b, and it's a super-Earth sitting in its star's habitable zone, the region where liquid water could, in theory, exist. Scientists used a technique called metastable helium spectroscopy to detect helium escaping from the planet's atmosphere. And here's the genius part. You can't have helium leaking unless there's an atmosphere to begin with.
That's such a clever way to prove it. But let's be clear. This doesn't mean the planet is habitable, right?
Right, and that's an important distinction. This discovery doesn't tell us what the atmosphere is made of or whether it's breathable. What it does tell us is that rocky planets around red dwarfs can hold on to their atmospheres, which was a big question mark before. It's like opening a door to a whole new set of possibilities for finding life.
So it's less about finding life right now and more about proving that the conditions for life might exist elsewhere?
Exactly. And what's exciting is that this method, detecting helium, can now be used to study other rocky planets. It's a breakthrough not just for this one planet, but for exoplanet science as a whole.
It's amazing how much we're learning about planets so far away. But let's bring things a little closer to home. Our next story is about the sun and a hidden switch-off moment that could help us predict space weather years in advance.
This one is fascinating. The sun operates on an 11-year cycle of activity. More sunspots, more solar storms, then it calms down and ramps up again. Predicting the strength of the next cycle has always been tricky, but researchers have identified a turning point they're calling a switch-off moment.
And what exactly is switching off?
It's the mechanism that drives the most extreme space weather. These violent solar storms are powered by the sun's differential rotation, twisting up magnetic fields near sunspots. At a certain point, when those active regions drift within about 15 degrees of the equator, that twisting engine shuts down.
So, by observing that switch-off moment, we can get an early read on what's coming next?
Exactly. The number of sunspots at the switch-off point closely matches the strength of the following cycle. It's like a sneak peek into the sun's future. This could give us up to 7 years of warning about intense space weather, which is a big deal for things like satellites and power grids.
7 years of lead time is huge. Do we have any predictions for the next cycle?
An early forecast suggests that solar cycle 26 will be moderate, with a peak sunspot number somewhere around 100 to 120. It's still early days, so the numbers could shift, but having any reliable signal this far out is a major step forward.
It's amazing how something as massive and complex as the sun can have these subtle patterns that we're just now starting to understand.
Absolutely. And speaking of patterns, our next story takes us back 201 million years to the end-Triassic mass extinction, where ferns turned Europe into a wildfire engine.
This one blew my mind. The idea that ferns could fuel thousands of years of wildfires is both fascinating and a little terrifying.
It really is. After the end-Triassic extinction, which was driven by massive volcanic activity and global warming, the tall forests collapsed. In their place, ferns took over, spreading across what's now northwest Europe.
And those ferns became kindling?
Exactly. Ferns are fast to regrow after a fire, so each wildfire cleared the land, the ferns bounced back, and the fresh growth fed the next fire. It created a feedback loop that kept the landscape burning for millennia.
That's such a vivid example of how ecosystems can lock into destructive cycles. It's a reminder of how interconnected everything is, and how climate change can amplify those connections.
Absolutely. It's a cautionary tale, but it's also a fascinating glimpse into Earth's deep past. And speaking of glimpses into the past, our next story is about a 1,600-year-old Egyptian mummy and a surprising discovery, a page from Homer's Iliad.
This one feels like a detective story. A Greek epic tucked into an Egyptian burial. What's going on there?
The mummy was found at Oxyrhynchus, an ancient site in Egypt. Resting on the abdomen of the mummy was a papyrus containing a passage from the Iliad, specifically part of the catalogue of ships. What's remarkable is that this is the first time a work of literature has been found used in this way. Usually, papyri found with mummies are magical or ritual texts meant to protect the dead.
So, why the Iliad? Was it seen as sacred?
We don't know for sure, but it could reflect how deeply Greek literary culture had woven into life in Roman Egypt. The Iliad might have carried a meaning powerful enough to accompany someone into the afterlife. It's a beautiful, human detail that connects us to people who lived 1,600 years ago.
It's amazing how a single artifact can open up so many questions about culture and belief. And that brings us to our final story, a protein in the brain that might help defend against Alzheimer's.
This one is about SORLA, a protein that appears to protect neurons from the toxic tau tangles associated with Alzheimer's. It's not a treatment, but understanding how SORLA works could point researchers toward new ways to combat the disease.
And tau tangles are one of the big culprits in Alzheimer's, right?
Exactly. Tau tangles are closely tied to the loss of brain cells in Alzheimer's. SORLA seems to act as part of the cell's housekeeping system, helping neurons resist the toxic effects of tau. It's a promising piece of the puzzle, but it's important to stress that this is basic research, not a cure.
It's a reminder of how complex the brain is and how much work goes into understanding it. But it's also hopeful, knowing that scientists are making progress.
Absolutely. And that's the thread running through all these stories. Whether it's planets, stars, ancient fires, or the human brain, science is about curiosity and discovery. It's about asking questions and finding answers, one step at a time.
Well said. And on that note, I think we've covered a lot of ground today. Any final thoughts?
Just this. Stay curious. The universe is full of stories waiting to be told.
Couldn't agree more. Until next time.